Hi, I'm Vicki Murley, the Safari Technologies Evangelist at Apple. I think that when a lot of people use an iPhone for the first time and they see some of the features that we've built into our applications, one question that you can sort of see in their faces is, how does it do that? Or how did the iPhone get so smart? You know, I turn it on its side and the photo that I'm looking at rotates and scales to fill the screen. Or I push this one button in the Maps application and it knows right where I am. How does it do all that? How does iPhone know where it's located or which way I'm holding it? In this presentation, I'm going to talk to you about how to leverage the frameworks behind those effects and how you can use them to deliver a compelling and unique experience to people using your application on iPhone. Information about an iPhone, such as its location, orientation, and acceleration, which is how the device is moving, really allows you as a developer to deliver a highly personalized experience to your users. First, I'm going to take a little bit of time to talk with you about static device information. For the most part, this is the kind of information that you fetch as needed with a single method call. Whenever you need this information, you fetch it manually. After that, I'm going to cover dynamic device information, information that changes as the state of your device changes. In most cases, your code is updated repeatedly as state changes via a callback. Location information, orientation, and accelerometer information fall into this category. So let's get started and talk a little bit about static device information. There's a bunch of general information that you'd expect to be available on any kind of system, desktop or mobile. It's all pretty basic stuff. To begin accessing static device information for iPhone or iPod Touch, you'll start by creating an instance of the device programmatically in your code. Once you have this instance, the properties that you can access include the system name, the system version. This could be useful if your application has any kind of minimum system version requirement. The model name, possible values here are iPhone or iPod Touch. And this could be handy if you'd like to tailor a single application to have different behavior for each device. And lastly, the user-defined name. This is the string that shows up in settings on iPhone and in the iTunes control panel when you sync your device. So if I wanted to get static device information in my code, it would look something like this. I start off by creating an instance of the current device, and then from there, I can access properties such as the name, model, system name, and system version. At the end, we've printed a string that reads, Vicki's music is an iPod Touch running version 1.3. So that kind of covers the basic information that you'd expect to see on a desktop system that is also available here on Apple's mobile platform. There are a few additional pieces of information available from the iPhone SDK that are unique to iPhone and iPod Touch. For starters, there's the unique ID. The unique ID is a string based on various hardware identifiers on iPhone, and it's guaranteed to always be unique. This string can be useful, for example, if you want to store some kind of information remotely on a server. Maybe you're a game developer, and when your application launches, you want to present your user with the high scores of everyone playing the game in the whole world, not just the high scores for that particular single user. The last piece of information to mention here is orientation. Possible values for orientation are portrait, landscape right, portrait upside down, landscape left, face down, face up, and unknown. On iPhone and iPod Touch, you can get the current orientation of the device by querying the orientation property, or you can register to receive the UI device orientation did change notification, and your code will be alerted when the orientation changes. Now I realize that the last point here about the notification kind of breaks with the theme of static device information, but I wanted to mention it here because all of the information I just talked about and the properties that you can use to access that information are all in the same header file, which is uidevice.h. Now let's move on to dynamic device information, specifically acceleration. iPhone and iPod Touch both have a built-in accelerometer which detects how the device is moving. Unlike orientation, which gives you more of a snapshot of how iPhone or iPod Touch is positioned, The accelerometer provides continuous updates to your code as the device moves, providing knowledge of instantaneous changes. Since updates are continuous, data from the accelerometer is useful for any application that could use the movement of the device as input. Some applications, such as games, might use accelerometer data for long periods of time, like the entire duration of a game. But it's important to remember that you can also use accelerometer data in a different, unexpected way for short periods of time and in non-game applications. For example, if you had some kind of drawing application, you could use input from the accelerometer to clear the screen while the device is shaken back and forth. Information from the accelerometer is available for 3 axes within a 3-dimensional plane. When iPhone is facing you in upright portrait mode, the x-axis runs horizontally across the middle, the y-axis runs vertically across the middle, and the z-axis runs from front to back through the device. Note that values can be negative or positive depending on where they fall within this 3-dimensional plane. So now that you have an idea of what accelerometer data might be useful for and what kind of data is available, let's talk about the 2 primary classes that you'll be using to access this data in your code: UI accelerometer and UI acceleration. Getting data from the accelerometer is really easy. There are basically 3 steps to begin utilizing this type of data in your application. First, get the shared accelerometer object. Next, set the interval at which you'd like the system to deliver acceleration data to your application. The default time is 100 times per second. If you're a game developer who needs very detailed information very frequently, the default rate is probably a good fit for you. If you're using acceleration data for a custom user input that's really just a component of your application, like the drawing example that I talked about earlier, you could configure this interval to update your code less frequently. Remember that on all mobile devices, including iPhone and iPod Touch, battery life is critical. Every little bit that you can do to reduce CPU usage will improve battery life in the long run. Lastly, set the object that you would like to receive acceleration events in the shared accelerometers delegate. Data is sent to the main thread continuously until you remove this delegate. That's pretty much it. It's very simple. So that covers UI accelerometer. Now let's move on to UI acceleration. After you execute the 3 steps I just mentioned with the UI accelerometer class, a UI acceleration object is returned to your code. UI acceleration is a very simple class. It really only has 3 read-only properties, X, Y, and Z, which are used to report the current accelerometer readings on each of the 3 axes. So that's it for the accelerometer and acceleration data. As you can see, it's pretty simple to get started using dynamic device information in your code. Now let's move on to location data. Location data on iPhone is enabled by the Core Location framework, and it requires a connection to a network. When you use Core Location, there's a lot going on behind the scenes. iPhone is using built-in hardware to communicate with Wi-Fi hotspots or cell towers, or both, to triangulate a position fix on your device. Once it has this information, which could take a few seconds in areas with low Wi-Fi or cell tower availability, it reports this location to your code. As the position of your iPhone changes, or as better signals become available, your code is notified with an updated position. Many details are available to your code when you're using Core Location. First of all, you can get a 3D geographical coordinate for the device, which is reported in latitude and longitude and includes horizontal and vertical accuracy. Second, you can get the altitude and the vertical accuracy of that altitude, and you can also get the time at which the last location was determined and the previous location that was determined. So now that you know all of the data that you can obtain using Core Location, let's talk about how to start using it within your code. You can start using Core Location in just a few basic steps. First, create an instance of a CL Location Manager object. Next, assign a delegate to it. After that, set your configurations. You can set a distance filter to determine how much you want to let the device move before receiving another location update, and you can set a desired accuracy. You should configure this parameter according to your usage scenario. For example, if you want to report the local weather in your application, you could specify a broad accuracy. A broader accuracy means fewer Wi-Fi hotspots and cell towers need to be contacted, and that means decreased power consumption. So, choose your desired accuracy wisely. Once you've set your configurations, you can begin getting location updates in your code by calling Start Updating Location. When your code no longer needs location data, or when a suitable location has been obtained, call Stop Updating Location. It's important to be a good citizen on iPhone when using core location to obtain location data. Specifically, be sure to start and stop your location updates as needed. If you've watched the Key Practices video, you know that mobile devices achieve their long-lasting battery lives by turning off specific parts of hardware whenever possible. Since location updates are powered by iPhone hardware, obtaining location updates for the lifetime of your application, from its launch all the way until the point when the user quits, instead of as needed, can really drain your user's battery life. The definitive place to look for iPhone developer resources is developer.apple.com/iPhone, where you'll find the orientation videos, technical documentation, and lots of sample code. Also, feel free to contact me at vicky@apple.com with any questions you have about the material in this video. In this video, you've seen how easy it is to integrate the amazing amount of device information available on iPhone, such as orientation, location, and acceleration data, directly into your application. All of the technology that we use at Apple to engage our users is now available to you. I look forward to seeing your application use these capabilities to create a really unique, personal experience for iPhone users.